Hey kids, welcome to another integration day. This time I'm not going to give you an integration rule. I'm going to give you an integration technique. This integration technique you're going to use with one of your rules. And so far you only have two types of rules: the power up, divide by the power up rule, and your trig rules. Right? The trig rules that I've given you so far, and I've given you 6. So this integration technique is called U substitution. That's not my language. It really is called U substitution, but this is me. Suck it up. Here's the reason why I call it suck it up. Because when you are doing derivatives and you have a composition, you have to spit out the derivative of the inside function, right? The function that's being composed. So when you're going backwards, if your derivative was a result of the chain rule, you need to undo the chain rule, which means you've got to take that derivative of the inside that was spit out and put it back. See my little cup with my straw? Listen. Suck it back up. Okay? So I'm going to give you an algorithm that's not going to make sense until we practice. So just stay with me here. Find your inside function means identify the function that was composed into another one. You're going to call that inside function u. You're going to differentiate u with respect to x. And then you're going to multiply both sides by dx so that you get du all by itself. And then you're going to ask yourself some questions. Do you need to get the x stuff by itself? I know that doesn't make any sense to you right now. I know. Then you're going to substitute so that your integral is all u stuff. Sometimes you have a constant multiple that needs to be osmosised outside. Again, this is an optional step. This is an optional step. Might not have to do those steps either time. Then you're going to integrate what I call the outside function. I know those don't make sense, so just wait for my example. If I'm doing an indefinite integral, my final answer is plus c. And then I have to resubstitute, right? If I started with x stuff and I replaced and made everything a u, my final answer needs to be x stuff. Put your x stuff back. However, remember with a definite integral, I'm not going to get any x or u stuff. I'm going to get a number. So when I'm doing a definite integral, I have a choice about substituting. That, again, doesn't make any sense to you right now. That's okay. I will tell you what I mean as we do examples. But I wanted you to kind of get the algorithm down. So while we're doing examples, you can refer to each one of these steps. Okay? Your goal is to take an integral in terms of x and get it all in terms of u. Do the integration using either the power up rule, divide by the power up, or the trig rules I gave you. Those are your only two options right now. So here's an integral where I want you to recognize there's a composition in the integrand. You are anti-differentiating this function. This function is a derivative. Somebody already took a derivative. You need to undo their work. Who is inside? Do you see anybody, any function that has been shoved inside of another one? Hopefully you see that x to the 4th minus 1 has been pushed inside of squaring. So x to the 4th minus 1 is my inside function. It's been shoved inside a squaring function. So that's step one. I've identified my inside. Now name it. My inside function is u. Name it x to the fourth minus 1. Take the derivative. The derivative of u with respect to x is power down, subtract 1 from the exponent. Take the derivative of u, then get du by itself by multiplying both sides of your equation by dx. Get du by itself. Then press pause. Pause. Get your highlighter out. Whatever you've identified u, color it. Whatever you've identified as du, color it. Ask yourself a question. Do you have everything in the integrand covered up except for the outside function? Yes, right? U and du has colored everything up except for the 2, the squaring. That's what I need. So u and du, there is nothing left in my integrand in terms of x, nothing. So rewrite, right? I paused. I did not need to do any rewrite with any of this x stuff. So now substitute. In place of x to the fourth minus 1, I wrote u. In place of 4x cubed dx, I wrote what it was equal to, du. I can now just integrate. I don't need to osmosis anything. That is an optional step. Integrate your outside function. You know how to integrate stuff squared, don't you? Which rule is that? Is that the power up or is that a trig rule? Oh, hello, it's a power up, right? You're going to have u cubed over 3. There's my u. There's my du. Integrate u cubed du, and I get u cubed over 3. Because it was indefinite, I had a plus c. Should do it over there. So I've done that step. I do not have a definite integral, so this does not apply to our example. But I have not, so I integrated the outside function correctly using the power up, divide by the power up rule. Now it's time to resubstitute. My original equation, my original problem had x's in it. My answer has a u in it. That's inappropriate. Put the x's back. In place of u, put what u was equal to. Done. What? Hey, what if I'm unsure? What can I do? When you do an antiderivative, you can always check your work. Take the derivative of this. The derivative of this function. Take the derivative with respect to x. Bring the 3 down. Copy over the middle. Subtract 1 from the exponent. There's still this 3 here, right? Spit out the derivative of the inside. These 3's cancel out, and I'm left with x to the fourth minus 1, all squared, times 4x cubed, boom and boom. And the derivative of the constant, of course, is 0. OMG! U substitution is highly useful. It is used so much. It just takes getting used to. So don't worry if this feels awkward, weird, and you're just like, I don't even understand what happened. Let's practice. Suck it up, baby. All right. Whoops, sorry. An indefinite integral. Step 1, who is inside? It might be easier to see this way. There is your u. Step 1. Step 2, differentiate with respect to x. Step 3, multiply both sides by dx. Pause and get out your highlighter. Find u and color it. Find du, 2x dx, color it. Is everything in your integral covered up except for the outside function? Yep. Therefore, I can go directly to the substitute stage. The substitute stage is you're going to take the integral and have no x's left. You're just going to have u to the 1/2 and then replace 2x dx with du. Now integrate stuff to the 1/2. How do you integrate stuff to the 1/2? Is that your power up or your trig? Duh, power up. So that's u to the add 1 divided by 3/2. I think I'll multiply by 2/3. Right? Power up, divide by the power up. This is indefinite. So plus c. Because it is indefinite, I started with x's. I need to put my x's back. What was my u equal to? Done and done. What can you do if you don't believe me? Take the derivative of this. Take the derivative and you are going to get 1 plus x squared to the 1/2 times 2x. Woot woot! All right, now I'm going to erase this and do the same problem, but with a definite integral. So to do the definite integral, I ignore everything that I did, right? My first steps are the same. I don't mean ignore. I ignore the limits of integration. I identify my inside. So that is u to the 1/2 du was 2x multiplied by dx, right? I had du dx. I went there. I highlighted. There's my u. There's my du. The only thing that wasn't, right? The only thing that wasn't highlighted yellow is the square root, the power of a half. Oh, darn it. But oftentimes we forget that if our function is in terms of x and our integration is with respect to x, the limits of integration are numbers on the x-axis. These are no longer numbers on the x-axis, right? These are now u numbers. How do I figure out when x when x is 0 and x is 1, how do I know what u is? Hello, u is equal to 1 plus whatever x squared is. So when x is 0, what is u? How about when u When x is 1, what is u? So when you substitute, that substitute step has to be well, I guess that's all right that that's blue. Everything that is in terms of x. No, I don't want it to be blue. I want it to be yellow. Every x thing has to be substituted. The function with x's in it, the variable of integration has an x in it, and the limits of integration are x numbers. When you substitute, you have to substitute everyone. Now I'm going to I get the same thing as I had before, power up, divide by the power up, which is really multiply by the reciprocal. I don't need a plus c. I have a 1 and a 2. So I have 2 to the 3 halves and 1 to the 3 halves. Whoops. 2 to the 3 halves is the square, right? Square root of 2 cubed. And 1, of course, is 1 times 2/3. I think I'll just leave my answer to that since that's not an integer. Done and done. Sometimes changing your U bounds really messes with kids' heads. I'm going to warn you though, AP is going to force you to change your bounds. They want to make sure you understand that when you use U substitution, everybody needs to be in terms of U. But when so again, they're gonna find very clever ways to test you on that knowledge. But for now, when you're just learning, I'll teach you a way that you can kind of slide around that. I'm going to go from this step, 2/3 U to the 3 halves, but I'm going to leave. I'm not going to put on my limits of integration yet. I'm going to resubstitute. So remember, U was 1 plus x squared. To the 3 halves. And again, you can leave your 2/3 in here, but it's just a multiple. Keep it on the outside. Now I've put x back. I can put these x numbers back. And sometimes if it helps you to keep track, do this. Notice what I get then. 1 plus 1 squared, which is, right, I'm going to put in a 1 here, and I'm going to get 1 plus 1 squared, which is 2 to the 3 halves, minus, put in a 0, 1 plus 0 squared is 0 to the 3 halves. Whoops, I'm sorry, put in 0 here, I get 1 plus 0 squared, which is 1 to the 3 halves. And then, lo and behold, see that you have the exact same thing. Okay, so to be honest, in years past, I've kind of skipped over this dealing with the U bounds, and I have always just taught it this way. Before you do your definite integral, resubstitute your x so that just to eliminate that step. But we've started seeing more and more problems where AP requires students to not evaluate, but to set up in terms of U. So we want to make sure that you practice when you're using U substitution, it means to substitute everyone. Now, of course, you only have to worry about that when you're doing a definite integral. Let's do another one. All right, this one's a dagger. See if you can tell why. If you want to pause the video and start the problem, and then restart when you find the dagger. There's my composition. Ah, did it again. There's my composition. So this is really 4x minus 1 to the 1/2 dx. 4x minus 1 is inside. Power of 1/2. So u is going to be my inside function. Du dx is going to be 4. Multiply both sides by dx. Pause. Get out your highlighter. U is 4x minus 1. Du is 4 dx. Bother. Remember when remember if you look at your algorithm, right? Your list, your recipe that I gave you. At this step, I said, question, do you need to get the x stuff by itself? Watch how clever I can be. Here's the x stuff. I got the x stuff by itself. Dx is equal to 1/4 du. Right? Do you see what happened there? So now I'm going to do my substitution. And I'm going to have integrate 4x minus 1 is equal to u. The outside function was not highlighted. And dx is equal to 1/4 du. Now look at your algorithm. After substitution, what's underneath there? Do you need to osmosis? Yes, you do. You need to take this multiple of 1/4 and osmosis it to the outside. And now go about your integration business. Integrating u to the 1/2, this is old news. This is u to the 3/2 divided by 3/2, which is time 3/4 plus c. Put my x stuff back. I don't have a definite integral. Just put my u back, 4x minus 1, and I'm done, right? No, who did I forget? You forgot your osmosis. Your 1/4 is there. So I have 1/6, right? 1/4 times 2/3. What if you don't believe me? How can you check your work? Take the derivative. Bring down the 3/2, copy over 4x minus 1, subtract 1 from the exponent, spit out the derivative of x, which is 4. OMG. Crazy, whack, funky. Hey, didn't I just call that example 4? Oh, no, that was example 3. Okay, here's example 4. You ready? Composition. 3x minus 1 has been shoved inside of cosine. So this time, my inside function is 3x minus 1. Who's my outside function, though? Cosine, right? Do you see what I mean by that? 3x minus 1 is a linear function that has been composed inside of cosine. So my inside function is my u. Take its derivative. Get dx by du by itself. Just kind of did that in one step. Pause. Get out your highlighter. U is 3x minus 1. Bother. Du, what's the situation here? I need to get the x stuff by itself because I need to highlight just dx, not 3dx. So get dx by itself. Now get your highlighter out. And substitute. Everything has been highlighted except for cosine. So the integral of cosine of not 3x minus 1, but what 3x minus 1 is called. Replace dx with 1/3 du. Osmosis the 1/3 to the outside. Bother. Integrate. The integral of cosine is sine of u plus c. Don't forget your 1/3. This is an indefinite integral, so just put your x stuff back. How can you check my work? Take the derivative. All right, not too bad. Use substitution, not a new rule, a new technique. We'll do more practice in our live session. I'll see you then.